Now you might be saying to yourself, hold on, Dr. Imholt, something's wrong here. You normally start these videos out with some kind of a picture of the Nobel laureate. That doesn't look like a Nobel Prize winner. Well, it could be, I don't know. But no, this prize has again to do with X-rays. Now this is the fourth Nobel Prize where X-rays have kind of showed up. So I thought we'd do a quick little backstory on how we got where we are. Given that we've only discussed 16 Nobel Prizes and 4 of them have had to do with X-rays, you can really see why back in 1901 the first one was given to Rontgen for his discovery of the X-ray, which actually took place in 1895. So people realized how important it was so quickly. He won the prize just 6 years later, something that would almost never happen today. Now Rontgen's work with X-rays was in 1895. Now this fellow, Lenard, who won the Nobel Prize in 1905, actually did his work in 1888. His work, as you recall, was on his work with cathode ray tubes. He allowed ray tubes to exist, and that allowed Rontgen to actually do his work. Without that tool, Rontgen would not have been able to do what he did and discover X-rays in the time frame that he did, and then go off and win the Nobel Prize. So what you see is the 1905 prize, which was work that predated the 1901 prize, was absolutely necessary, or the 1901 prize wouldn't have existed, and X-rays wouldn't be as far along as they are. And I certainly hope someone bought Lenard a glass of wine for enabling the previous prize winner to exist. Then, of course, in 1914, von Laue won the prize for his work that was done in 1912 that showed that X-rays were actually diffracted through various crystals. And what that proved was that X-rays were actually traveling as a wave, not as a particle, which at that point in time, nobody was exactly sure of. So what's that? 1, 2, 3, 4 prizes? 3 different prizes so far that had to do with X-rays. Then, of course, there was the 1915 prize by the father and son team Bragg, who used X-rays to determine the atomic structure of crystals, where in different crystals were different types of atoms, how was the whole thing put together. So X-rays turned out to be this shockingly useful thing, but wait, X-rays aren't finished yet. They're coming back for one more. That brings us to the 1917 Nobel Prize in Physics, which was won by this gentleman, Charles Barkla. He was a British physicist, and what he did was he used X-ray scattering. So when an X-ray passes through a material, it has a tendency to scatter a bit. And he determined that you could actually use the angles at which the X-ray scatters to determine something about the atomic structure of that particular material. Now think about this for a second. If you use a very pure material, you can actually learn a lot about the individual atoms inside that material. Everybody kind of knows now what gold does. Everybody understands how copper works. Everybody understands all of those different things. But he didn't at this point in time, nobody really necessarily understood that. So X-rays are essentially just very short wavelength things, but the way that X-ray passes through an element of high atomic weight is different than how it passes through something of low atomic weight. So when it's higher, the X-rays have a tendency to be collectively absorbed, and some secondary emission might be obtained. So the X-ray may actually excite that other atom to go off and do something on its own. So really, this is the early stages of the nuclear world, where we're now starting to interact with things at an atomic level, and not at a nucleus level yet. That's what nuclear really means, is you're interacting with the nucleus, or something's going on in the nucleus of the atom, but we're getting really close to that. Now we're interacting on an individual atom level, which is just really cool, because before that you could pick up a block, you could pick up a baseball, you could throw it, you could understand it at a much larger scale, but now we're starting to get a true understanding of that atomic realm, and that is the future of physics even today. So far on our journey, 4 different people have won the coveted Nobel Prize for their work with X-rays. One in the mix here won their prize for the ability to generate those X-rays exactly where you want them in different ways. That was the CRT. So the CRT had a lot of other applications as well. So you see what's happening here is we're building up this foundation that leads to modern physics. Without these discoveries all kind of sitting around the same place and using the same equipment and learning more about the world around us, modern physics wouldn't be set up the way it is. And more importantly, modern engineering and a lot of the items we use and love every day, a lot of the medical equipment we use and our lives depend on, wouldn't be available without this foundational work that was awarded by the Nobel Foundation as outstanding science. Stick with us on our journey. This brings us up to 1917. A lot more to go, and it only gets tinier from here. Don't forget to hit that subscribe button. Click like on the video. That really does help us out with the algorithms. Everybody have a great day. We'll see you on the next one.